Hello friends, आपको नमस्ते. So today in this video we will create a model which can detect grocery item. Okay, so before explanation, please like, share, and subscribe my channel. So let's get started. Let's first connect the this with the GPU. Then it's taking time for the connection. Please wait. It's connected now. This is Roboflow. A package which is required to download dataset from the Roboflow, and this is our dataset. Okay, let me run this cell. Our dataset will get downloaded. Okay, it's taking time. Wait for it. Okay, started downloading. Okay, completed. You can see we could get a dataset grocery item 2. Now here I want to rename this grocery item 2 from grocery detection dataset. Okay, so this way we can do that. Just run this cell and your dataset name is changed. Let me refresh it. Okay, we can see it. Let me see how many classes we have. So we have 17 classes, and these are those classes which is grocery item detections. Okay, let me close this. Now this is the dataset, and the format on which we have downloaded dataset is YOLO v8. Okay, then images, and this is labels. Okay, so let's start it. See, these are the libraries which is required to train the model. This Torchvision is, you can say, for fetching the architecture like SSD. Okay, wait a second, let me open some tabs, then that VGG16 and one Coco dataset. Okay, so wait. Okay, so this is we are Torchvision just to upload the architecture of the SSD model. Okay, then this DataLoader is used to load the data in batches and used for the training, and transformer is just to add a data augmentation if required, and SSD classification head is this one. Here we load uploading. We can fetch it easily, and util is basically the function used by the Torchvision detection model. Okay, like box matching or loss helper. Now this is the weight file which we are using, SSD300 VGG16 weights file. Okay, and which is trained on Coco dataset. Okay, so let's get started. I have already run this cell. Okay, now this is a class which we created. Why we have to create the class? So let me explain you. Custom class is created to load images and their corresponding annotation file, convert them into tensor, and return them into a format that PyTorch object detection model can understand during training. So this means in short, in simple way, that it convert those annotation files and annotation file bounding boxes and images into a tensor format, so that the model which is used for training can easily fetch it, because those models are trained on PyTorch, and PyTorch basically understand a tensor language. So that's why it's required to convert those annotation files and bounding box into the tensor format. So that's why we, for conversion, we use this class. Okay, it's important that the function name, that init, length, and get item function names will be same. Otherwise, during training, it will throw error. Okay, so first of all, what are the parameters which we are using is the image directory, annotation directory, and transformation for the data augmentation. Annotation is basically the list of all the text txt file present in a particular directory. Okay, so this will be initialize the parameters, also variables, self.image directory, and self basically we can use to uh, uh, what we can say, that we can easily fetch that variable throughout this function without passing it in the in a function. Okay, let me explain you clearly what you. So in simple terms, we can say that self is used to access the instance variable like image directory annotation and transform throughout the class without passing those variable as a parameters. Okay, so this will in simple terms, let's say use of self here. These are the instance variable which we have which we have initialized. Length, give me how many annotation, best pass cell annotation. We will get how many number of images or txt file we have. Okay, for training purposes. Get item basically active during training, and this is idx. it will get index value. After passing that into the annotation, you already know what is annotation. Annotation is a list of all the txt file present in that particular directory. Okay, so we have to get the annotation. This annotation give me the annotation file name. After that, we want to get the image path. How we can get it? Just pass the image directory like this one, and this annotation we only want we do not want last four character like dot txt. We do not want that, so that's why -4 is required. And just add .jpg. This way you can create your image path. After that, we read that image path. Image, if it is not there, it will throw this error. Otherwise, nothing will be shown. And then we convert that image into the RGB, because we're reading it in the CB2 form, CB2, in which read the image into BGR format. Then we require the image shape and height and width. It's required. I will tell you why. Wait for the seconds. Okay, and then annotation file. Path, how we can get it? Just annotation directory, annotation, you will get the annotation file. We will read that, we will open that annotation file in read mode, and everything will get stored in this F. So we want to read this data in line by line. So how we can do that? Just use for loop line in file. First line after getting the first line, that first line will get converted into the list, of the string, into the list of the string. But okay, so for that, use line.strip.slave. Everything will get stored in data in a string format. Okay, for example, let me show you one txt file data. Some time to open. See, close it. So here you can see those variables. One is a class id, this one is a class id, then this is x center, y center, width and height. Okay, and you can say those those are values are only in a 0 to 1 format, 0 to 1 only, normalized format they are. Okay, so you can what I want to tell you, this line dot strip dot split, when you really, when you will do this thing, your data, your this complete line here, this complete line will store in this data variable in a string format in a list way. Okay, if suppose I will do data 0, it give me class id. If it data, I will class id in a string format. If I will do data 1, it will give me this x center in a string format. Okay, so that's why you can see that for getting the class index data 0, then into, then x center, you can see the x center. After getting fetching the x center, I convert that into a float. Then I have multiply it with the width. Why we are multiplying it the width? Because I want to unnormalize them. Okay, so that's why. Then same for the y center, same for the box width, and same for the box height. This way we get unnormalize those values. After that, we just want x mean, y mean, x max and y max value. So how we can do that? You can easily just box width divided by 2, then minus x center, you will get the x mean. Y mean means box height divided by 2, they give you the y mean. And box width divided by 2 and x max, you will get the x max. Those two values are the top left bounding box coordinates values, and this is our bottom right coordinates values. After that, we will append those into the boxes. Okay, here this whole thing is happening for the single image. Okay, this why everything will store in this. If suppose multiple bounding boxes will there, we generate a list of that, and labels also be generated. After that, we are adding the class index +1, because the in, you can see the SSD model, we are using SSD model which is trained on Coco dataset. So for example, this is the Coco dataset. You can see that in Coco dataset, this is, you can see SSD300 VGG16 weight Coco V1. It's trained on Coco, so its zero index value is already fixed for the background. Another class is this one. Total classes which we have is 91 classes. So that's why we class index +1 is required here. Okay, then everything will convert into tensor format, convert to PyTorch tensor. If any data augmentation is applied by the user, is suppose it is not none here, you can say it's initially it is none. If it is not none, then we apply the transformation to the image, and thus we just, after that, we create a dictionary with two key values, boxes and a label. Boxes give me the bounding box details, bounding box list if it is bounding box list if it is multiple bounding boxes there. Okay, then labels also get a multiple bounding box, multiple labels will be there. After that, we just return the image and target. So this way we convert the boxes and image into the tensor, then we return it. After that, how we are loading this model, so let me explain. Let me explain you. So here I will explain you how you load the model, how you will change the model according to our number of classes. So let's get started. First thing, it is this is a main line which I will create. This is a function which we have created this, which return the model. A number of classes which we have is 18. Why 18? You can see that we have 17 classes. 70 classes is there, but background is also included, so that's why total class will become 18. Size will be 640. After doing from calling function, it's moved to here. Here we first you can say load a pretrained SSD model, which is this is a okay. Let me do something. Okay, there's something mistaken here. Okay, it's over. So here, see, you can see we are load the model using Torchvision dot model dot detection dot SSD300 VGG16, which train on Coco V1 dataset. Okay, here we load the model. Now let me show you the model, how the model looks. Okay, so let me print it. Now let me run this cell. So here it's our model look like. Okay, this is the whole model. It's look like, you can see it. Now what the main thing is there, what is in channel, what is number anchor, and why we are calculating them. So for that, let me show you the image of this model. So this is a model VGG16, and you can see that these are the sequential layers. Every sequential last layer is connected to the head. One thing is this one, every sequential last layer connected to the head. And you can see those output of the sequential last which is connected to what thing is connected. Output channel of these sequential last layer is connected to the head, and those output channel for this head act as a input channel. So that's why we have to calculate the input channel, so that we can change this head according to our number of classes. For that purpose, we require the in channel. And how we can do that, just use utils retrieve output channel and just pass the model dot backbone and the size. Okay, so this way we fetch the in channel. Let me print them. Okay, you can see at and we got the list of in channel 512 1024 512 256 256 256. One thing is that you can see the last sequential last layer is connected. So how we can get the in channel? So for example, 512 come from okay, so this is the first sequential, and this first sequential last layer is this one, and and output channel is this. Oh, wait for this is 512. And for this sequential last layer will be output will be 1024. So that's why here 1024 is coming. And this is 512 256 256 256. How they are coming? So come back. Okay, where I will explain 1024. This is 512, this is 256, this is 256. Okay, and you can see here 3 into 4 means 2 sequences later. That's why 256 will be there. Okay, so that's why total 3 will be there. And you can now we want number of anchor boxes. How many number of anchor boxes for per classes we required those values also. So how we are getting that? See, for getting that, we required model dot anchor generator num anchor per location. We will get that number of anchor for per you can say per layer we get it. For example, you can see number model, it's not going down. Let me, okay, perfect. So here we get anchor generator, and when you will go to where it is uh, these are the aspect ratio clip. Okay, it's number and model in model anchor generator and num anchor per location. This is a function which give us number of anchor for per location per layer. Okay, and this line basically have those function which give us the number of anchor per location, per layer, sorry, per location you can say, or per layer. It's up to you. For let me explain, let me read this line. SSD uses anchor boxes at different aspect ratio and scale. uh, this line retrieve the number of anchor generated by the model. Okay, number of anchor for per location. Now let me print those values. With those values, those things is also required. Why required, I will explain you. If suppose, see, for a first layer number of anchor is 4, so this calculation, this 364 for a, this is a main head, this is a head, this is a classification head, and this is 364. How it's coming, you can say for the first layer the anchor box number of anchor boxes is 4. So if you multiply, open the calculator, it's big one, let me minimize it. Okay, you can see for the first layer the anchor boxes is 4. And for the classification head we require and this model is trained on 91 classes. So when you multiply 91 into 4, you will get 364. And you can say for the second layer number of anchor boxes is 6. Number of anchor boxes is, so how it's PyTorch is coming, just multiply 91 classes into 6, you will get 546. That's why it's going giving me this 546 value. Now we come to the regression hat. When you will come to the regression hat, how this 16 is calculating, because regression hat is represented for the bounding box, and bounding box have only four coordinates values, dx, dy, dw, dh. So only four values, so four prediction will be there. For so number of anchor boxes for first layer is 4 1. So when you multiply 4 by 4, you will get 60. And when you multiply for the second layer, it's 6. So when you multiply 6 into 4, you will get 24. So this way, those calculations is happening, and we want to change this head. So that's why required engine also and number of anchor boxes also. After getting those values, we will just we will change this classification head according to our classification head. So for that, model.head.classification head is replaced with SSD classification head with some in the internal which we have created, calculated number of anchor which we have calculated, and number of classes which we have. So this way in channel and out channel is required. Okay, now okay, then here what we are doing, okay, now I adjust the transformation side to match the input image. Here we adjusting the explanation. This line modify the model transpose setting to adjust the input image size, minimum size and maximum size determined for resizing behavior. So this is what happening doing here. Main thing I've already explained you, why we are calculating integer and number anchors boxes, and how we change the classification head according to our number of classes. Okay, after changing everything, I have printed that model here. Okay, and you can see that our number of classes which we have is around 18, and first anchor boxes number of anchor boxes is 4. Now you multiply 18 into 4, you will get 72. And second layer has 6 anchor boxes, so when you multiply 18 into 6, you will get 108. And same way for the 4 is 16, 4 anchor boxes and 4 prediction, 16, 24, 24, 24 is remain the same. So this way the calculation is going on. Okay, and this way we define a model and get a model. So now this is the main thing. This is a train image directory, this is annotation directory. And after that we train annotation, means number of image list, image number of name of all the txt file present in a particular directory is getting in a list format. After that we create a object of a class which we have created. Okay, so how we created, just pass the train image directory, train annotations, train annotation directory, and transformation. True tensor, what is the use of true tensor is that it's convert the dimension of image from height hwc to chw. It's convert that's it's required. And why by converting, because during training it's required. Okay, then what is the use of data loader? See, create a data loader to load training data in batches of 4, shuffle the data epoch, and uses a custom collect function. What is the use of custom collect function? To group images and target separately, useful when sample of images size is different. Okay, so that's why this collect function is required. Shuffle is true and batch is 4, and we just pass a train object, and our train data loader is we get. So let me run it. And this is the length is means 1574, means you can say that 1574 into 4, these are the number of images which we have. 1574 is the length of the we can say length of the let me print length of the batches you can say. But now let me print. The object is what with the object name trained dataset. Trained dataset. The function which we have is length. That length function we want to call that length function. Okay, we won't call to that line function, and here it's give me detail. Okay, so 6277 is a number of images which we have. Okay, so now here we the main thing be setting learning rate and optimizer here. What is the use of this line? It decide that it says that the model and all images and labels has to be on a same device by in GPU or a CPU. Okay, that's why we use is. If torch.cuda is available, it means CUDA. If it is not available, means CPU. Then we move the model parameters to selective device. Okay, so we will move the model to a selected device. After that, we calculate only the parameters, because optimizer is used to update the parameters. So we want those parameters which should be updated during training. So we every parameter have one you can say value, that is speed or required grade. If it is true, that it means it is trainable. And so here we create a list of all the parameters which is trainable during training. After that, we use the SSD, which optimizer we are using, up to the torch.optimizer.sgd. Okay, and optimizer update weight model and using training and learning rate control update size. It's control rate. Okay, rate means speed of training as well control, and momentum is speed of the conversions. Okay, and after that we want scheduler also. What is scheduler means? Scheduler basically update the learning rate value. Okay, and which we are using LR scheduler step x step LR. For how we are fetching it, just use torch.optim.lr scheduler.step r and optimizer. Then step size is 3 means after every third deploy we change the learning rate value, and gamma means 0.1 means is multiply learning rate value with 0.1. This is a simple example which I have shown you how its learning rate is going. And the number of epochs I have trained for 5, but I have trained for 1 because it's behind number of images which we have is 6277. It means it takes the time. So I just want to train this model on for 1 epoch only. Okay, we have a you can say I have a model which is trained on 5 epoch. I will show you the result of that also. Okay, so don't worry. And here we checking the data loader means we want to visualize our images and check that our data tensor means the data loader which we have generated is correctly assigning the bounding boxes to correct image. So how we can do that? Just we want to plot 16 images, sorry, 2 images. So one row 2 column, figure size will be 10 by 6. Plot.subplot which we are using here, x is in a 2D format and figure is representing for entire subplot. After x.ravel, we x is converted to 1D format. Why? We just want to ease for iteration over the subplots. Then this first we have to create an iterator for the train data loader. After that, when you use next, it give us images and target. And when you will find the length of this images and target is 4, because it's give me one batch images and targets. And these are the you can say classes including the background, and these are the color sample for each class. Okay, now just iterate. We want to iterate for the 2 because just we want to plot 2 images. So here we want to the use of this permute means you can say when you will get the images those images due to transformation due to two tensor function, those are in a C, H and W dimension. What we want for the plotation, we want those into the HWC format, CHW, and but we want in a HWC format. So how we can do that? Just use index image idx dot permute. Okay, till here it will convert it. Then after we want in a numpy format, because those in a tensor format, so I have to convert it into numpy format, so that's why its numpy is required. Okay, after that we multiply those value with 255, then s type and p unit copy. So this will be get the image. After that we just uh, we want a label also. So how we can labels means we want a label also and bounding box detail also. So how we can do that? Just first we get a target, then target boxes give me the boxes, and those also is a numpy tensor format. So here we also convert them into numpy format. Data type will be int, and how we can get a labels? Just dot numpy and you will get a labels. After that we zip boxes and label and iterate at same time, because labels particular box have particular labels, so that's why we want to zip and iterate over those one. And after that this is x mean, y mean, and x is y max. This way we get it, those values. uh, and after that, what is which color we want to display according to label. So how we can do that, you can see I have used label -1. So why I have used label -1? Because label start from 1, because 0 is reserved for background class bg, but Python list are 0 indexed. First element is at index 0, so we subtract 1 to correctly map the class label to the color list index. So that's why we label -1. And after that, we just draw the rectangle with the color which is selected, and put text with the color which is selected. But I don't want those color to be on a text. I want color to be black because it's more visible. Okay, now let me run it, and then I will show the image, and the dust access will be off. Then let me run it. You can see this soap, two items. It's correctly assigning the bounding box with correct labels. Now let me come to the training part. What is happening here, I will explain line by line. So tqdm, just for easy to to get this filled bar, you can say. For that purpose we require tqdm. First, initially train loss is used to you can say to store the loss value for each epoch I am talking about. For each epoch I want to you can say I want the loss value for per epoch. So that's why this is those value will show in this. And after that, I will iterate for how many number according to number of epoch I will iterate over it. First I will show this masses. Okay, then it should be compulsory that model should be in a train mode, otherwise it should be problem. Because model or train, when the model is a train format, then only the parameters should be update, or we can say we upgrades should be update. Otherwise it will not update. Then initial training loss is 0. And you can say this tqdm basically train data loader is you can pass for getting a tqdm. To apply the tqdm, we have to first give the train data loader, then length, then the line which you want to display, and leaves will be true. After that, we just iterate over the p bar, and we will get the images and target. This image and target is in a, you say we get a 4 images and 4 targets values, because the batch is 5 4, because now this is happening for per epoch per batch. And it is important that our model and everything, images and everything, should be in the same device. So that's why we make those values should be in the same device. After that, we just pass the images and targets, and we get a loss dictionary. After that, we just sum up all the values, so all the loss item value present at particular loss tick. Okay, after using when for loss in loss state, it will give me loss value. We will sum those loss value and we'll get a complete loss. After that, you can see this is a formula of new weight. New weight is equal to all weight minus learning rate into gradient. Okay, so gradient tell how much and in which direction our weight should change to reduce the loss. So optimizer zero grade. Optimizer zero grade is means is key clear the previous batch gradient value. If we do not do that, means if we do not do that, then this that particular previous gradient value will get accumulated to the current gradient value, and the proper changes of the new weight will not happen. Okay, so that's purpose optimized zero grade is required. Now losses dot backward means here will calculate the all weight value. It will compute the gradient of all for all weight value. It will compute gradient for all weight value. Here updation of weights is not happened. Here just a calculation is going on. Optimizer dot step will change all weights value. After that, we just batch loss will be losses dot item, means this for one batch this will be the losses dot item batch loss. We will accumulate those loss will in a training running loss, which is initially it will be 0. After this, scheduler dot step is there, because after third epoch learning rate value will be changed for that purpose. Then after, for how we this way we calculate the epoch loss. Okay, so this will be calculate the epoch loss, and this we show the train loss. Now let me run it. Okay, but this is work for only for one epoch, because you can see it takes 3 minutes for one epoch, so and we do not have this much time. Okay, then this way we save the model. After training, we will save that model. And this is a representation, you can say this is a representation of 5 epoch, when the model is in 5 epoch. How we can do that? Here first we want to know the range. So range will be 0 1 length train loss plus 1. Okay, so this will be create a range. After that, figure means 85 means the figure size. And what you want to plot, this is a you can x range, this, and this is a y values, and marker, yes, you want to mark every value. Then limit line with value 2, and these are the x label, y label, and title, and this will plot the grid, and then b plot the show. I will not run this because only one epoch value one epoch is running, so it will does not show anything. But just you can see this is a you can say five epoch you can say five epoch graph. Now everything will be the remain same. This I have explained you that device is required. This is a create model, give me the model. After that, this line give me how you load the model, which is trained on custom data set. Now here model should be in a evaluation mode because it's required. Because here we are not changing the model, we are now we are evaluating the model, like how the model is working on unseen data set. The model to be in the same device, I have already explained you. But at that place we are representing two images, but here we are representing 16 images. Two tensor, it's important that the transformation which you applied during training on the images has to be performed during testing, otherwise it will throw the error. Okay, then text directory, then text it make the list of all the images name present at particular directory. This is a you can say classes, and these are the colors. Sample we plot 16 times. Then how we can get the image path, just use OS path join, then text directory, then randomly select one image file name. This way we will create the image path. Then we will here we wait a minute. So here we image open using using a you can say pill. You can using a pill that image that we open that image in the convert into RGB. After that, it's not required to convert that image. It might be possible that some gray image can be there, so we have to convert that image to RGB. So it's not required. Okay, it's up to you how you will add or not. After that, we convert that image into MP array because CV2 rectangle and CV2 put text work on an NumPy array. So we have to convert that image into NumPy array. But in model we pass that pill image only. So first of all we apply transformation to convert that image to tensor, because it convert when we apply the to tensor transformation, it means it's convert from it dimension converts it from HW, so it convert to CHW. Then what is unsqueeze? Unsqueeze basically add one batch dimension to in the image, because you already know here during training we pass the images. Here we passing the image in a images in a batch format, so same way we have to pass it. So for that purpose we add one batch dimension to the image like this. Okay, now after that we torch no grid. Then with torch no grid, okay, no gradients, no operation you can say. Then prediction model, then we pass the image in a tensor format. Then to get the result of the single image, will you use zero index value. After that, how we can get the prediction boxes, because all thing has to be in a tensor format, and all things has to be in a GPU on a different device. So I want those all things has to come to the CPU. So that's why we use boxes CPU.numpy as type conversion. This way we get a label, and this we get a score. Okay, and single box have single label, single box also have a single score. So that's why we zip all this, and you can when you print the length of each box's label and score, you will get the same thing. Okay, then you will zip it, you will get a box label and score. And after that same thing, label start from one, because I already know explain you what like why we subtracting label management, and everything remain the same. Okay, so now show you let me show the result of the model which is trained on one epoch. You can say the training has completed. Model is saved. This is SSD custom.pth. Now let me run this. The model which is trained on just one epoch, but nothing will be shown. No bounding box will be shown, I think, according to me. Okay, because it's working. See, it's working very well. I think so. The model which is trained on one epoch also working very well. Okay, this is stationery, chocolate, soup. Okay, the model which is trained on one epoch is also working very well. But you can say sometimes two detection is there. Okay, but if suppose I will, okay, if I will increase this score value to 0.8. Now let me see it. Okay. Now double bounding box is not coming for a single image. Some places detection is not there. Okay, you can see some there detection is not there. Now you can either increase the score or you can increase the epoch value and train the model. Okay, now let me show you the result of the model which is trained on the, you can say, 5 epoch. Let me upload the model. So let me upload the model, come back with that. So friend, I have already uploaded the model which is trained on 5 epoch. This is bash.pp. I have changed this path also. Now let me show you the result, the model which is trained on 5 epoch. Okay, I also maintain the score. I think so. I maintained the score 0.8. I think the error will come, which is the error. What is the error? Bash.pt. What's the error means? Weights only load failed in PyTorch. We changed the default value of the weight only and torch to load the file. Okay, let me check. So friends, I think there is no problem in the code. I re-upload the model and then I have run this, so it's perfectly working. So let me show the result of the model, which is children just 5 epoch. So let's get started. And I have not changed the score value also 0.8. Okay. In the previous, for when one epoch is training, there is some detection is not happening, but here I think the detection is completely detected. Okay. Soup, and this is dry fruits. If I want, here also it's not detecting properly, but here it's properly detecting. Now let me decrease this score. Let me keep it 50%. I can keep it. Now let me show you the result again. So let's wait for the seconds. Okay, so it's doing very well. Okay, now you can increase the epoch's value and give more training, and somewhere where the detection is not happening, it should be there. Okay, it might be possible that data set for that current it's not data set for the particular image for the, oh sorry, particular class is not very much. So this is a way we train a model on SSD model on a custom data set grocery item. So if you like my video and gain some knowledge, please like, share, and subscribe my channel. Thanks to all.